Kaya, and welcome to the next video. This one is about infinite geometric series. So it's understanding limiting behavior as n approaches infinity of the terms Tn in a geometric sequence and its dependence on the value of the common ratio r. So we're going to start off with discussion about how any sequence with an r between -1 and 1 will gradually approach 0. For example, our third times a third is 1/9, 1 to the 27th, 1 to the 81st, will slowly, very quickly, in fact, become very close to 0, though never will reach it. In the last video, we saw that the summation of the first 9 terms was approximately 0.499975. In that same sequence, s at 20 is pretty close to 0.5. And so a reasonable conjecture might be that the sum of more and more terms is approaching 0.5, or s at n is approaching 0.5 as n approaches infinity. If r is between -1 and 1, then the infinite geometric series a plus ar squared, etc. is convergent, and the sum to infinity is given by s at infinity is equal to a over 1 minus r. For examples today, we've got find the sum to infinity of the series half plus a quarter plus an eighth. Starting off again with what we know. We know that a, the first term, is a half, and the common ratio is a half as well. Half times a half is 1/4, quarter times a half is 1/8. Plug those into our s at infinity equation. We've got half over 1 minus a half is equal to a half over a half, which you may know is 1. Starting off pretty easy. Our next one, we've got example 28. A square has a side length of 40 centimeters. A copy of the square is made so that the area of the copy is 80% of the original. The process is repeated so that each time the area of the new square is 80% of the previous one. If this process is repeated indefinitely, find the total of area of all of the squares. So they've kind of made you do a little bit more maths this time. In that first you have to know that the area of the square is going to be 40 squared, so 1600 centimeters squared. The r being 0.8, the 80%. It's pretty straightforward. Sometimes they will try and trip you up by doing this kind of like, the side length is 40, but the area is what we actually care about, not the side length. Plugging that one into our equation, we get 1600 on top, a over 1 minus r, 1 minus 0.8. So 1600 divided by 0.2 is 8,000 centimeters. And we just restate that in a sentence format to answer the question. Again, it's asking, find the total area of all the squares. It's not asking you to find s infinity, it's asking you to actually answer that question. Our last example today, example 29, express the recurring decimal 0.32 recurring as the ratio of two integers. I don't really like the fact they use the dots above them. I prefer the line. So just to show you what 0.32 recurring looks like, it looks like 0.32 plus 0.0032 plus 0.000032 or 0.3232333333. As a result of that, we know that our first term is 0.32 and the rate is 0.01 or 1/100th to get the extra 2 zeros there every time. Chucking that in, we get 0.32 over 1 minus 0.01. So 0.32 recurring equals 32 over 99. So our ratio of two integers, 32 and 99. Thank you very much. Very short video for you today. Hopefully you've got time to watch it. Enjoy.